Hi, my name is James Thompson.
My name is Ryan Guthrie.
And we're representing Group 14 of Senior Design for Mechanical Engineering. Today we have the NERF Modulus Regulator, which is marketed for ages 8 and up.
So some of the features of this gun that are new to Hasbro is select fire technology, where you can select from single fire, tri-burst, and continuous fire. And when the magazine's out, red light flashes and you reload. Also, some of the other attachments that come out of the box are a stock and a barrel attachment that can also double as an underbody attachment.
Although this is a great product, we have a few designs that will make the gun even better.
So some of the problems with the current design is that if you're going to fire the gun, sometimes the gun can jam, and then they have to open this door to get that out, shown here. They have to open up the door, pinch their fingers in there, try to reach around, try to grab the dart, which is very difficult, and then drop that, and continue firing. But see, in that much time, you can get blasted. So some of the things found in initial testing is that the gun would not fire consistently in continuous fire modes, and we think this could be due to either dart shredding or dart jamming, and I'll demonstrate now. So as we can see, the darts are not firing consistently, but they did not jam this time. So some of the things we noticed when darts got jammed is that they would actually be shredded, as you can see here, from the belt tab. And that's one of the things that we wanted to fix in our update design. So as you can see, it's just a nice long streak and tears some of that foam away. And that's something we want to fix. The group has identified several areas in the original feeding system that contribute to the dart jamming and shredding issues. The original feeding shown in this video consists of 2 gears and a belt that rotates around them. The belt has a tab that pushes the darts from the magazine into the flywheels. This tab only connects with the top of the dart, and so when the dart gets jammed, the tab continues to rotate and shreds off some of the foam. One of the main reasons that the darts jam is the misalignment out of the magazine. As shown in the image, as one dart is being fed into the flywheels, the next dart starts to leave the magazine. This causes the darts to be fed into the flywheels at an angle, and the implications of this are further discussed. So we have here NERF's old funnel design, which, as you can see in the middle, there's a small skirt. And one of the issues that we found is that if the dart is not properly centered, it can get caught up, and that causes jamming. As well as the dart enters this funnel, there's a lot of alignment issues that we want to try to fix with our new design. The weaknesses of the blaster were then translated into constraints and criteria for the product redesign. The important requirements that will be fulfilled are listed. The main constraints that are being addressed in the redesign are that the gun should fire at least 5 magazines without jamming or shredding darts, and the prototype should fire at a more consistent rate. All the safety requirements outlined in various toy standards, such as all plastic components being brightly colored so that they cannot be mistaken as real gun components, will also be met in the final product redesign.
And here we have implemented our new design, which features a spring-loaded rack and pinion. The pinion has 12 teeth in order to allow the rack time to slide back due to the spring force. We've also implemented a funnel. This funnel is located right here, and the dart goes through it prior to entering the flywheels. The new system also fires darts. As you can see, this dart is shredded. In the previous system, this would not have worked, but in this system, it has no issues. In our current design, we have maintained plenty of the functions from the previous version. Single fire is still preserved. The LED light still indicates when the magazine is empty. It also fires shredded darts that the previous design would not. This is because our rack pushes the darts through into the magazine versus just pulling them with a shear force. No darts have jammed or been shredded in this current design as well. Range also appears to be perfect. As you can see, this is still a prototype. We had to remove the previous battery pack in order to make room for the current design. However, we have redesigned a shell in CAD that will actually hold the new batteries. The spring also lost tension due to hyperextension during testing. Once we find a more suitable spring, continuous fire and tri-burst will both be restored to the current gun. Ultimately, we find that our group has designed a superior system as it does not shred darts and it continues to preserve the life of the gun.
So one of the problems that we're facing with our current prototype is that we can't find a spring that will be able to extend as far as it wants to without damaging the spring. So these are some of the examples that we have where they will either stretch the desired distance that we want, or they can't and then they get permanently damaged. So, or the other issue is that they are too stiff to where they'll overwork the motor, and we can't get the spring to extend the distance that we need to push the dart to the flywheels. So until we can find a spring that meets these requirements, we recommend not going into production with this prototype.
When performing a cost analysis, the team looked at the new components being added to the system as well as the components that could be eliminated. For the new components, which are shown to be the rack as well as the pinion, several posts to mount the system as well as a spring to retract the rack. Next, the team looked at the eliminated components, which are 2 gears as well as the belt that currently feeds the darts. Finally, the team examined the existing components whose geometries we've modified for mass production. These are the funnel, the outer gun casing, as well as the gray sub-body. Once these molds are changed, the same amount of plastic will be used in the manufacturing of each of these modified components, making a cost difference essentially negligible. The estimated cost of the injection molds for the various new and eliminated components were calculated based on size, geometry, and tolerances. The rack is estimated to cost approximately $750 and the pinion is estimated at $750. This makes the total cost of producing these molds $1,500. For the eliminated components, both the gears are estimated to cost between $500 and $1,000 each, making the total mold cost between $1,000 and $2,000. This means that the upfront difference in cost for Hasbro is plus or minus $500, which is less than the cost of 10 units. An analysis can be performed to estimate the manufacturing costs of each of the components during the mass production phase, as well as to develop this cost. The components were listed in an updated bill of materials. The total cost of the individual components is between $20 and $25. If the gun is still sold at its original price point of $58.99, NERF's profit margin will virtually remain unchanged.
As you can see in the video, we truly believe that we've designed a superior gun. We believe that NERF will be really happy with the results.
Thank you so much for watching, and happy foam flinging.